world where space and time are intertwined, one man dared to challenge the status quo. His name? Dayton Miller. His weapon of choice, a flute. But not just any flute. This instrument held the power to unleash the ether, a pervasive medium once thought to fill the universe. Miller, a physicist.
All right, everyone. Hello and welcome. This is an Ether Cosmology Flat Earth Gang on Clubhouse special edition. We're having a little hang session going over the conceptual model and just showing off some of the features, how everything works, and doing a little Q&A and stuff. So we'll go ahead and get right into it. Let's see here. And then we are streaming on YouTube too. So if you're not on Discord, but you still want to see the visuals to follow along, the link to the stream is somewhere. Kat will provide it. All right, here we go. So on the GitHub here, let's go to the GitHub. You can click on Conceptual Flat Earth Model, and then you could click on this link over here, and it will load it into your web browser. And then if you're on a phone, if you're on Android, you can click the little three button, the little three dashes up in the top right to get to your browser settings. And then what's that?
Hamburger.
They call it a hamburger.
Oh, do they? Yeah. So you can click the hamburger, the three dots, or what have you. And in any case, scroll down to save to home. And then when you click save to home, it'll ask you if you want to install it as an app or install like a bookmark to go back to it on your home screen. But in any case, you can install it as an actual Android app, and it doesn't have any tracking stuff or you don't have to sign up or enter your email or anything. It'll just work. And then so with that, you can just run it on your phone. And I think that works the same on iPhone as well. But if not, you can run it straight from your browser in any case from right here. So there's a couple of important tabs here. There's an About tab on the top left, or I'm sorry, top right, and there's an Info tab on the bottom right. So on the bottom right Info tab, there's links to YouTube channels and Discords and different media platforms that everyone's on. So Clubhouse Gang's on there, Twitter communities hosted by Brian and Ken are all on there. So you can also select your language here. So suppose you speak a different language. There's 18 different languages there. But this got lost in an edit, it looks like. Nope, we're good. Okay, so when you click on the About tab, you'll see this, you'll see some information here. And we'll go over what that is in relation to. So this is a conceptual model based on the positions of the stars, and it's purely kinematics. There's no dynamic assertions here for gravity or anything like that. It's just position over time following Kepler's laws. We use a geocentric ephemeris, which is just basically time and angle, when this thing is going to be at this position at a specific time, and then calculating out from there. From the geocentric position, which would be in this case from the center of Earth, as they would calculate it, and then as opposed to doing it from the barycenter of the sun for the heliocentric ephemeris. Now there are multiple ephemerises included that we can compare, but we'll get to that as we continue. But in any case, the purpose of this is to show that the argument that we've been making for a long time is that we're using a coordinate system based on a hemisphere of vision that's related to where positions of stars once were at a specific time, and then calculating out from that epoch, from that reference point. And so when we say that, units of measurement are part of the graticule itself and now it's internally consistent, well, the purpose of this model was to show that relationship by just taking the angles and time and not asserting any units of like distance or radius values or anything like that. And we actually followed the Tang Dynasty's celestial sphere model that was kind of pioneered right out of the transition from AD to BC, or whatever, BC to AD. And that's when the Chinese changed their cosmology to geocentric flat earthers, where the earth was flat, but the heavens were curved. And basically they were, their hypothesis was that they had a limit of vision, and that's what they based everything off of. So they came up with their own way to relate an angle in the sky to distance traveled on the ground using Polaris. They first started off using shadow lengths and then calculating out the what the shadow length would be for any time of day of year uh, based on uh, based on your latitude. And so once they had that reference table, they could tell latitude by shadow lengths uh, using a stick essentially of a certain length. And from that, they found that that was inaccurate. So during the Tang Dynasty, a second method was introduced where Yingzi used a length of a rope essentially to do like a chains and rods type method. And using that, he established like a 351 Li per degree relationship, and they didn't call degrees degrees, they called them a do, and a do, instead of being a ratio of 1 divided by 360 for 360 degrees in a circle, they used the sidereal degree, so it would be 365.25. So the only difference really is that they had a slightly smaller degree. And then so anyway, that Zing guy related the how many lengths of rope it took to traverse on the ground to relate to 1 degree of change in the sky for them under their system. And once they had that, you know, they then they established latitude and longitude using a celestial sphere. They never used any sort of radius component, but they did have the ability to calculate distances and use a latitude and longitude coordinate system. And so we started with that in mind, just using angles and everything, and then we have the system converted into what their situation, or I'm sorry, what they were doing with degrees and angles. And then we show the equivalence by the same way that you convert an inch into a meter. You just divide one by the other, and then you get a conversion factor that you multiply the original unit by, and then that gives you what it would be in the converted unit. And so if we take Earth's radius multiplied out by, let's see, Tang sphere.
Well, it uses the unit sphere, right? The importance of that, angular inputs only, like
Yeah,
elevation,
yeah,
direction.
right. It started with the unit sphere, but then when we apply the Chinese method of units for how they related the celestial sphere for the north and the south, we get these units here where we have an arc length in the sky, and we have a radius value for a circle. We have a height to the heavens, and then we have a diameter, circumference, all that jazz, and it's all related in units that correspond to the angular change of Polaris over distance, the same way that the globe lads would say, "Hey, 60 nautical miles per degree," et cetera, et cetera. Same exact scenario. And then so you could take our circumference and divide it by Earth's accepted value for circumference in kilometers, get that conversion factor, and you could see what it looks like, in familiar units. But everything works in the Chinese system, and then is converted to what the globe lads would say. It defines the globe using degrees and latitude and longitude. But yeah, it's just ratios. It's internally consistent. The Li is no more correct than the meter. If we had the actual length of rope to define it that was used back in the day, it would be, no more incorrect than what the meter would be. And since we can backwards convert it anyway, it really doesn't matter. We could just, arbitrarily set a new one and measure out 1 degree and then calculate out the rest, because that's all really anyone has ever done. And so another thing that we have for this is you can click this over here to enter fictitious observer mode, and this will anchor to the part of like the center of the map, which is what it's in reference to how the globe is always referencing where a star should be by referencing a fictitious observer. That's how they linearize the 60 nautical mile per degree rate, because the stars don't actually follow that. As they go from your zenith to the horizon, they start to linger longer than what's expected from that rate. Now, of course, that's a whole separate discussion with refraction and whatnot. But the linear rate is what defines where the star should be. So you can see what that anchor point looks like. You can drag around the map here. Oops. You can drag around the map and go to different locations using that. It's a good way to move. And then you can calculate distances between 2 points by clicking the little compass here. You can define 2 points, and then it'll use central angle theorem to show you what the distance would be. So in this case, this is 17,900 leagues from here to here, which comes out to be 50,086 kilometers when you convert it. So there, yeah, go ahead.
It's a central angle. So what we're doing is we're still using the graticule distances, but we're using proportionate angles so that it offsets any distortion you're seeing in the visual map there. So when we say we're always getting the same distance as the graticule, I think the central angle math is the best way to show that.
Yeah, the angle is invariant whether it's done in the south or in the north. So, like, we get into the scenario where they say, how does this flight route work in the north or in the south? Well, that can be shown here because when you're using, the graticule, the latitude and longitude coordinate system, it doesn't matter what map projection you're using, it all represents the same thing. Just because something looks bigger in the south doesn't mean that it actually is. That's just an aspect of the projection. So, what we could do is we can go to flight routes, go to equal flight, and we could see the comparison in real time of a flight in the north and a flight in the south, where they both take off at the same time, they both arrive at their destination in the same time, but the length that they travel is visually different, but the arc length, based on the central angle, is the exact same no matter if it's in the north or the south. So although this looks bigger, if you were to transform it to a different projection, you would see here that actually the same size. They're traveling the same distance. So it doesn't. So people will often draw like straight lines on this map and then say, hey. Why doesn't it work on a flat Earth? Well, they're using the coordinate system incorrectly. So
Yeah, you could even say that
that's
they're
why.
just calculating it on WGS84, and that this is showing you WGS84, and that we're both utilizing the same model to calculate distances since they're both based on angles to the stars. And the only thing that would differentiate them would be if you actually independently verify your geodetic datum or the datum at the heart of that model, which is a whole different argument having to do with measuring meridian arcs, which doesn't even differentiate either way. So when we say we use both, both models are able to make use of abstract spherical coordinate systems.
And one of the so another thing that I wanted to show too is how this is all based on what a single observer once saw during his zenith measurements to track where the star once was, and then add 15 degrees per hour to it, essentially at the sidereal rate. So what you could do here is you could click on this button, go into first person mode, and you could see what how the sky looks for the observer at that relevant latitude. So here we're about at I think, what is this? Where are we at? We're at the 32nd. We're about like in Texas-ish. So looking up here towards the north, and another thing you can do here is you can turn on facing vectors. So you can see which direction you're facing, your azimuth ring. There we go. So when you turn those on, you can see where you're facing and whatnot, and then you could click on a different star and it'll start auto tracking it. So you can track its position and stuff throughout the day or whatever.
Turn on
go ahead.
star trails too. Can you track, like, if you hit a button here, wouldn't all things just start generating trails too, I think?
Yeah, I want to say it's one of these tracker options.
I was looking for it earlier and I was like, I hope Alan knows which button that is.
Yeah, it's in tracker options, and then you go to trace GP, I think, and then you trace it in the optical vault.
There it is. That's
Yeah.
it. So that just tracks everything. So you got satellite that whizzing by, but it's also taking perfect symmetrical star trails too at the same time. You can watch the little dipper circle around and make those 5 lines. I thought that was really cool.
Yeah, you can see what that looks like there. Let's see, optical vault, turn that off. So you can see the patterns that they all make under the projections, and then changing projection. Oops, it's going to make, well, it's supposed to not render the center one there and just render the one that's going around the globe projection. But in any case, you can see that under different projections, it all comes out to be the same. It's kind of visually bugged right now, so that's unfortunate.
Those inner, those like that pattern, man. I've seen that in a ferro cell, almost identical.
Yeah, so that specific one comes from the path of the satellites. So they all make that pattern. The ISS, etc., are all doing that, like a figure eight essentially. They're going in and out as they go around. Yeah, so let's see here. Vault of the heavens. There's different things you can do to customize this. So you could check out, you could like raise the, oops, hang on. So there's a star field that you could show the true positions of the stars, right, as they would be defined, and then you could see what that looks like in comparison to your into your dome of vision here. Let me turn off satellites so it's a little less cluttery. Satellites. There we go. Okay, so you can see how a flat disk of stars, and if you have a spherical vision, this is what it's going to produce. So when we go here and look in the north, we see what the star field's doing. Now you see everything's rising in the east, setting in the west as per usual, what we see in the north. And then when we turn around and look to the south, oops, let's go click south there. We turn around and look to the south, we see they're rising from the opposite direction and setting in the west. So you can go to the equator as well and look at what it looks like in the center. Observer 0, 0. So looking east and turning on ASI. Grid.
Let me ask you. Let me jump ahead and just ask you this: do you think when construct, they have to have an understanding of like limits, like some sort of range of like your horizon, your visual horizon?
What's that?
Do you think when constructing the globe, the globe radical projection, do you think there had to be any consideration for like your field of vision, like the distances, kind of like your horizon, your visual horizon?
Yeah, dude, it's kind of all built off half the sky, right? If you make the flat Earth disk 1, and then everything is half, and then everything's a ratio, then when you're using the unit vector, like the unit sphere and vectors, then everything always reduces to ratio, and then Kepler is just a ratio. So honestly, I think they figured this out, the ratios of it, and they had it all mapped out, and then you can just play with the constants to make it work, right? How far is it from all the ratios work to plug it in 3959 to getting the AU to pop out? Right, so when you reduce it to ratios, it becomes pretty clear that that's what the globe is, a system of connected ratios, and that the constants they give you to fill it out don't really matter. Like it's all about the ratios.
Yeah, so in terms of like, considering your field of vision, and like Shane was saying, I think it's just all based off of the sky. The Chinese did the same thing, came up with an identical system, and it seems like all the other civilizations were also using a celestial sphere model, because and then they would all have like different units of measurement to relate to the angular change of Polaris. So, when you went to this country, you had to use their stuff and it like got confusing or whatever. So because everyone uses this same system now, it's just associated through, oh, it must be globe, but really it was always underlined based off of just the change in Polaris over distance.
Yeah, man, you
Is
reducing it to bring in all the constants really was eye opener, because that stuff we say and we like conceptually understood, but to put it in the code and have it remove all the things that like that Globers think cause it was kind of eye opening. You'd be like, oh wait, everything still works if it's just ratios. So then the constants and the distances mean nothing. It means like it's just an aspect and output of the system. When you have this internally consistent system, then of course the output's going to be consistent, right? I think that's what we've been saying, and this is good proof of it.
if you swap to, oh, sorry, go ahead.
All right. I was gonna say it's a shot in the gut, and like the ego way, where they like the way the lore is sold to you. It's like, oh, it was because of our understanding of the dynamics, and we was like, it was all in, interconnected. And it's like, no, it's not.
It's not at all. And I'll show you what the difference between the dynamies and the kinematics are here in a second. But one of the primary things that I think is really cool to illustrate is, we say that we have a hemisphere of vision, then they defined where the stars, should be with a true position, calculating it out while referencing a fictitious observer. So we can see what that actually looks like in real time here. So we could take our observer here, go to the center, and bring the celestial sphere to the ground and look at the stars' ground positions 1-to-1 with Earth, the way that they merged the celestial and terrestrial sphere. This is Ptolemy's two-sphere model merged together. And you could see, like when they talk about in celestial navigation, when they say, sometimes, when you look up at the sky, it looks like you're the observer at the center of a concentric shell, and the stars are on the surface of it. Well, this is exactly what this represents visually. And then, of course, when you look at these actual celestial sphere for the globe projection, it would be this outer concentric shell, but the ground positions, are projected are projected right to the ground. And so you can even show that with the GP tracing. Let's see, it should play out. Yeah. So the positions that went from the celestial that were on the celestial dome of the observer are now on the surface of Earth. Uh,
Literally, the
relating that
creating the
change.
ground position. Yeah.
Yeah, relating that position from the celestial sphere from right ascension and declination to latitude and longitude, which is just which does another conversion for the observer to the observer's local tangent. So like the summation of all that creates this conceptual model, and it's actually pretty elegant when you look at it like that. But yeah, there's like just merging two hemispheres together with this fictitious observer doesn't mean anything is mutually exclusive when using this model. This actually is what removes the mutual exclusivity from it and allows us to use the same exact concept. Oops, that's going to be all weird. Let's see, trace
Nice.
GP, and then
That I say, no need to attribute to malice, or it could just be like, I guess, incompetence or whatever. Or just, do you think it's possible that we just got fucking carried away, man, with the elegance of it, and it wasn't, I guess that's just conjecture.
Well, so it's hard to say, right? But like when I took a look at what happened with the Chinese and the Japanese Buddhists around the 16 to late 1800s, and all the things that the Chinese did in terms of sailing. So like in the 1400s, they went and sailed to Canopus in the south, and then mapped out the same relationship that they had with Polaris in the north. They literally pioneered the symmetry of the two hemispheres of like merging them together. And for even 200 years after that, they were still geocentric flat earthers with the belief that, the ground was flat, the heavens were curved, and that's how you perceive them. And like they apparently knew about the 24-hour sun and all that, and they didn't care. And it wasn't until like about was so mainstream narrative is that around the 1600s is when the Jesuits came and started hanging out with the Chinese and started comparing maps and started influencing them. So it took 200 years of influencing using the same exact coordinate system, the celestial sphere, to convince to make them accept that the Earth is a sphere. They didn't care. They're like, we can navigate anywhere and we have our own tables. Like, and so
Dude, what
anyway,
you're
the lore goes that sorry, real quick. The lore goes that the Chinese, when the Jesuits showed up, that the Chinese were like, all washed out with astronomy and like couldn't really take it any further, or some weird narrative like that. And so they impressed the Chinese by fixing their calendar to to help them synchronize their holidays. And the difference between the Chinese calendar and their Jesuit corrected heliocentric master calendar was 13 seconds. So they helped them out by 13 seconds in timing difference.
Yeah, what you were showing before when you were tracing the GPs on the dome, like that was the creation of the so-called geographic position, the GP, which is the linchpin that ties the two-sphere model together, right? So, like, without creating a point on the terrestrial sphere that mirrors the celestial sphere, then there is no globe model. That is the thing that ties the whole thing together. When you zoom out and look at it, they're giving you like a God's eye view of what everyone like. So they're saying, hey, here's what everything really looks like if you were God, if you zoom out, based on everyone only ever seeing a hemisphere like we're demonstrating here. You can construct the celestial sphere model with the two-sphere model. Sure, you can create a terrestrial sphere nested within a concentric celestial sphere. You can mirror those points one for one, or the terrestrial sphere is just a one-for-one copy of the celestial. Of course, they share the same shape, so translation between them, is easy. That's cool. That's one possible God's mode view of what what it could look like if you could see beyond your hemisphere. And then there's alternative modes, like it could be the flat Earth version that we have here with a flat disk of stars that as you process in the limit of your view, then you see the same celestial hemisphere as you would if you were the surface under your feet was curving at that rate, right? Cutting off half the sky. There's also a dual pole mode where, hey, another God's eye view could be this. Maybe it's crazy like this. Maybe it looks like this. The whole point is they're all equivalent because nobody knows what the God's eye view looks like. We only ever see the hemisphere view. Everyone only ever sees half the sky. The globe model creates the other half of the sky with a celestial sphere. They use abstract math to represent those things that set, right, that go beyond your limit of vision. They mathematically construct them beneath your feet. The only difference for a flat plane using a hemisphere to represent coordinates in a sphere is a negative z-axis in the coordinates. That's the same thing. Hemispherical math otherwise is identical to spherical math. So of course we can use the same abstract spherical coordinate system. So like when we're looking at ground positions, linking them together, we're saying that there only ever is the stars, right? And the terrestrial sphere and or the globe is created from mirroring positions on a conceptual sphere from those stars. And that's what creates the globe model. And so this is just one of those a different God's mode view that it could be. The whole point is nobody knows the God's eye view, right? Nobody can zoom out and just see all the Earth. But if you construct different models based on what it could be, based on what you can see, then this is some of the crazy output. And I think this is probably some of the coolest ways to display the modeling that I've ever seen. So hats off to Alan.
So for sure, man, this is tough. I'm just kind of getting a really good look at it for the first time.
Yeah, we could play out a couple demos too. So we got the 24-hour TFE demo on here too. So from observer perspective here, oops, we see the sun.
Dave
and then
McKeegan kicked in. He's like, "This is impossible on your model," and I was like, "Oh, you didn't even see the demo where we showed it?"
Oh wait, why didn't
That's crazy.
Oh, because it was stuck in fictitious mode. Hang on. Should move to oh, because I clicked the wrong one. I'm clicking the north one. That's actually the issue. Okay. So here we go. So let's see, it's tracking the sun in tracking. And we could watch it from Nicki Minaj's perspective here. Vector. So track the sun. Okay. So
I'm having a look.
think,
Can you talk us through that one?
what's that?
Can you talk us through kind of how
Yeah.
Nikki's was seen?
Yeah, so she's looking off into space. It should be tracking better though.
There should be a viewing direction stick somewhere.
Yeah, it's right there. There we go. Okay. Now it should up. Okay, here we go. So you're about to see the issue here. So as the sun goes over here to the west, sets for the observer, or well, it would be setting, but instead it starts to go around the observers, in the opposite direction, And so when you look at it from this God's eye view here, you're going to see Nikki looking off into where no light rays, converge to. Yet there's a sun in her view. So here's the issue here. So if you're looking at it from the God's eye view here, you see she's now looking off into nothing as this plays out. And the sun's, over here. Oops. Play at normal speed, please. I like how pause is just still play and play faster. All right. Well, in any case, here, when you look at the globe projection from the God's eye view here, you're like, oh, it looks, she's on the bottom of the ball. But when you look at this God's eye projection here, hang on, sorry, it's playing too fast. When you look at the God's eye projection from another projection here, you see she's just looking in a circle. So it depends on what projection you're looking at here. And our argument has been that we don't live on a map projection. This is a God's eye view of two hemispheres merged together to make like a 3D model where everything converges to a point based on what an observer once saw, and it doesn't, it's not physically real in the sense that that's where that observer is going to be looking at that time. It's the direction in reference to the coordinate system. So what I mean by that is when you get down to Antarctica, which this hasn't been incorporated yet, but I'm going to add it soon, is magnetic declination maps and whatnot. Because when you get to Antarctica, there's like 260 degrees of magnetic corrections and whatnot. So we'll get to see a more accurate representation of where the observer would actually be facing with the God's eye view in reference to the corrections and stuff. So yeah, that'll be coming soon. But in any case, that's what it looks like.
Can you show me a couple of clips demos while we're here?
Oh, sorry. Yeah, it's on YouTube, Coffee.
So like let's say she's in the far south down in Antarctica. Is she still like mathematically seeing half like a hemisphere?
Yep.
And all the angles and all the trig just works out that way. Fine.
Yep. There's no different because there's no difference in the projection itself. What like looks disturbing is the God's eye view of what it's showing. Like what the observer would see on the ground here is going to be in relation to the direction that that's going to be shown like in the coordinate system here. So like especially when we account for the magnetic stuff, I think it's going to look a lot different for which direction she's actually facing. And I think that's gonna be pretty revealing here. So yeah, when you look at it under different ones though, it's all the same thing, just different perspectives of what an observer once saw, and then tying it to a place where it would converge to make it symmetrical when referencing this fictitious observer at the center. So it could be any one of these, but based on observation alone, that wouldn't be enough to tell you is kind of our argument. Even though it does look precarious, it looks a little unsettling even. And what we did do, well, God dang it, how do I get out of this demo or make it pause? What we did do is we tried to see if there was like a coffee cup caustic effect, and we did the ray tracing for that. And what ends up happening is the sun always shows up in the other side of it never like does the wraparound. It always shows up in the side facing towards the north. So you don't, so anyway, long story short, we ruled out like a coffee cup caustic type thing. So you can see that in here in the, let's see, if you go to the demo and then click on tracking options, what was it at? It's called dome caustic, this right here. So when we look at this from the third perspective here, you'll see that there's Oh, where is it? There it is. It's always on the wrong side of where it should be in any case. You can the orange dot here is would be the convergence point of the coffee cup caustic to where like the observer would see the projected sun or whatever in their hemisphere of vision. So but it's in the wrong spot. So we ruled that out. And then so Shane brought up ephemeris trackers earlier, which is an extremely important aspect here because we're told, oh, the heliocentric ephemeris is, the standard. You have to be heliocentric. How does a geocentric even work? Yada yada yada. Well, the driving thing when you load into the model is the Fred Esperneck geocentric ephemeris with that he calculated out, and so it takes positions from the heliocentric ephemeris, converts it into a geocentric ephemeris, and then that position is what's referenced in there. And then we have a geocentric. Oh, sorry. So anyway, that's what starts us off, and then we have what's called trepidation enabled, which is the summation of precession, nutation, and aberration added up together as a single thing. Back in the day, we found that the oscillation of the sky was observed, and it was like a total amount. It wasn't broken up into different, wobulations over the same axis. It was just a total amount, and so we have that incorporated here as trepidation. But when you switch to other ephemerises, you could disable that and then put on break it down to the same thing and show the same relationship. But that's what we got going on for that. So you could swap ephemerises here, but more importantly, what you could do is you could just click ephemeris comparison. And what that's going to do is there's going to be there's a little drop down menu over here. You can click on the top left. This is live ephemeris data. So whichever ephemeris is loaded in, you'll see the information regarding that particular the bodies that it's tracking. And then so you'll see the output here is in degrees and in the Chinese units for what we used. So there's no difference in, degree wise. But when you click ephemeris comparison, you can see the geocentric ephemeris, which is just the heliocentric ephemeris, which starts with the heliocentric barycenter, and then they transform, and then they just subtract that out, and they're like, look, we're at the geocentric position. So I just took that step out of it. I just where it just starts with the geocentric position, and anyway, same exact results. We got the Ptolemy ephemeris, which is invented by Petals back in the day.
Epicycles.
And then yeah, and I think he's 10 degrees off on the sun, if I'm not mistaken, because he used a different meridian line or something, they say. So there's a 10-degree discrepancy with that one with the sun, but it's related to his use of his meridian line. So there's the Fred Esperneck one down here, and then there's the VSOP over here, which is supposed to be the heliocentric dynamic one that's all tricked out. And you can see, if you pause this, you'll see that the difference in position from the geocentric, which is just position over time, to the full heliocentric dynamic barycenter sun reference frame of the sun calculated out pure geometry of the all that. You'll see the difference is in the arcs. You'll see the differences in an arc second range that would never be like, you would never be able to tell as an observer on the ground, like, oh, it's actually, I need to be 10 arc seconds close. It's not a real thing, so to speak. It is a measurable, calculatable, or it's calculatable like within the system, but like to actually measure it out, you get to a point where it just becomes pure calculation and adjusting to make your measurement match where it ideally should be in the sky. So, and again, this is referencing the true position, so not even the position that you do see. This is done after subtracting out all that and then, doing that. So the difference in totality there is, extremely minuscule. And that trend plays out for basically everything that's tracked here. So you can see all that in real time.
It plays out with every celestial object that you can track, which is all of them.
Which is all of them. Yeah,
This
I
is
think
so.
that's pretty. What's up?
I'm just saying this is so damn tough. I'm just wondering, like, how be able to kind of have you been able to kind of pass this along?
Also, it doesn't use any globe constants, no radius, no circumference, no AU, no big G, no gravity, none of that, and it just uses regular ephemeris data. What Alan was going over there was pulling recorded stellar data over time from known ephemerises. And when we put it on Twitter and tried to have people argue, like, hey, they're like, it's not a flat Earth app. You use VSOP once, and they're not going to go into the code and be like, well, listen, it only activates and pulls VSOP if you have the ephemeris selector chosen and you're not actively pulling a geocentric ephemeris. Then it will actively pull that data pipeline. But that was too much for people, so they were like, nah, it references VSOP. It's a globe app. You're all stupid. So there's a standalone separate app that we ran just for funsies that runs just on Ptolemaic epicycles. So it pulls no VSOP, no heliocentric, no ephemeris data, nothing whatsoever. And it runs identically to this one. So that was just to defeat the argument that, hey, it only runs because you reference VSOP in the code. Like, no. The ephemeris data pipeline is for comparison only. Like, we started out with the geo, and then we just wanted to see, well, what do all of them look like? Like, what's the difference between what Fred Espenag uses to predict eclipses to what they claim JPL produces when they're, actually, what we need is the mass of all orbiting bodies. We're going to conquer the 3-body problem. We're going to predict based on gravitational influences, and we're going to know the path of that object to a degree that we already knew with Kepler. Like, yay, science. Okay. Well,
To a degree that we already knew.
If you can put that all in real time and you can see the ephemeris' live time, it's like, so what was the need to pretend the dynamic? None. There was no need. The geocentric ephemeris based on periodicity and observation predicted that already. That was already there, and this shows that it's absolutely not necessary. And this is one of the coolest demos ever. The solar and lunar analemma at the same time draws it right in your azimuthal grid, and you can see how, if you want to construct a God's model of that, that's how you build the globe. You're like, oh, look, actually what's happening is the whole world is tilted at this angle that you see the sun at. It's not the sun tilting in the sky as it looks. What's happening is the inverse of that. The whole world is tilting around you to give it the impression that the sky is tilting. Like, that's, the birth of the ecliptic and how they tilt everything 23 degrees and all that stuff. That's actually attributed to Eratosthenes when he was like, why is my parallel light ray in Syene different from Alexandria? Oh, you know what it must be? Since we know light's parallel, the whole world must be tilted. That's why it's not 90 degrees. Anyway.
I saw a while ago you had some satellites whizzing around. Can you get like a Nikki view of that, like from on the ground, seeing satellites? And if
Absolutely.
There you go.
so, is there like a height? Has anyone kind of been able to calculate like what height might these things kind of like a minimum height?
So the height is just purely conceptual based off of matching the radius of the circle on the ground. So when you let me bring this up so you can see it. So here we have the radius of 20,419 lees, and then the height to the heavens is 20,419 lees, which allows us to have the arc in the sky from North Pole to the equator for 32,000 lees. So like establishing that same relationship now in terms of like how you perceive the altitude of the satellites and whatnot, they just go across the, your field of view. So that is totally capturable in the Nikki first person mode. So let me pause for a second. We'll grab a satellite, clear all, do enable all, and then there we go. We can see now they go pretty fast. So
These some real satellite paths, like
Yep, the one we got Hubble, the ISS, the James Webb, and then the rest are Starlinks, and then there's one called the Tiangong, but I think that's the Chinese ISS. If I'm not mistaken.
The one at the Earth looks really, really flat from in that footage they put out.
I think I was tracking a star there, actually. So here's, yeah, satellite tracking is way faster. That's what it should have been doing. So when we look at Nikki's view here, this is her tracking that position, getting severe whiplash. Hope she's okay. So let's see here. And then
Is it in
what's really
days
cool though,
days per second? What's the speed it's in?
the speed is normal speed, but the satellites go really fast.
Well, so you can speed it up and slow it down with those arrows, though, right? And right now you're rocking plus 0.42 dBs. So I don't know what DS is. So I was trying to figure out, is that
It's the half function next to the arrows. The 1/2 next to the 2x.
Yeah, and that'll speed
you hit
it
that
up
like
and slow
5,
it
6
down.
times. Yeah.
Yeah. So that speeds it up to a ridiculous magnitude.
Or slow it down so you can watch it go slow. Hit the half one
Right.
5 times.
Yeah.
Right. There you go.
Yeah, because I feel like you could extrapolate a lot more out of this in terms of like the actual size of one of these things, the angular size it might appear at a certain height, what kind of velocity it has to have to actually cover, I guess, ground speed, if there's even a way of knowing that.
Yeah, it would be really tough, but there's a couple of things that could be done. Like there's some people that have tracked using a radio telescope like a satellite going from horizon to horizon and stuff. So there's definitely some trig velocity over time situation stuff we could potentially look into to try and figure out some more concrete stuff.
Yeah, GP tracing in the optical vault is awesome. I think it's really cool. Satellites make the funniest pass. If you put it in the other mode, you can see they never approach the north or south poles. They make completely circuitous routes that never touch either pole for reasons or whatever.
I think they could track some of these Shaheed missiles next.
You could, dude. He put this like I think you can track black holes, quasars, every celestial body, like a day. Like I don't know how different it looks when you're tracking quasars to when you're not tracking quasars. To be honest, but it's possible. It's in there.
Looks the same. I haven't done the conversion from what's it called, like the epicycle thing to ellipses.
Right, from Ptolemaic to Kepler.
Yeah,
There's a lot of equivalence between those two.
I mean, it's just they're one z-axis transformation away.
Yeah, but like to view something as a series of repeating circles that oscillate versus a series of ellipses with, observed periodicity repetition is it's amazing, dude. Kepler is clearly more elegant, but dude, Ptolemy had it 2,000 years ago, and it would literally it could just build the whole quote solar system from basic circles. Like that was awesome. It's amazing. Still works today. Can tell you where shit is within 15 degrees. Like that's amazing. And they're like, yeah, but gravity. So that's how we know it's real, because I can tell you where it is better than 15 degrees. Like that's the scientific claim of today. They're like 15 degrees, hold my beer. Watch, I got gravity.
So there's also a built-in distance calculator for the Chinese version, or the output is in lees and stuff, but you can see what it is in kilometers as well. And you can see the central angle relationship and the sidereal angle relationship that the Chinese used. So like the idea that like we can't use a big part of this argument here is they say that haversine and latitude and longitude are mutually exclusive, and deriving distances within that coordinate system are mutually exclusive to a globe. But it's calculating two positions on the stars using a linearized version of the stars converging to the horizon. So that's not tied to that fictitious observer to make it linear in the first place. So when we use our 20,419 Lie radius for the haversine formula, we get the exact output that we need to get a meaningful distance relationship that would correspond to, hey, if I traveled this far on the ground, is this where this star would be at this time, at this, is it going to be at this angle? It's completely internally consistent to the units that are derived from the coordinate system itself. And then you can see the same relationship in kilometers, which is exactly what the globe relationship is. So the idea that we can't determine distances or use a spherical coordinate system because Haversine is mutually exclusive to a globe is incorrect. It's a calculator that calculates a specific part of a sphere to give a distance, to give like an arc length distance relationship, and the radius value is just tied to the geometry of the coordinate system that you're calculating in. It doesn't have to mean that the Earth is a globe to use that. If you're using two hemispheres merged together, linearized by a fictitious observer, then guess what? You just made a sphere that you can use a Haversine with your respective radius. So. Then I think to end on cool stuff to show, there's different stuff you can toggle on here. Like if you want to see the equator line, the tropics, all of that, you can see what those, you can toggle that stuff on. You can see the ground grid, the Tang sphere dimensions, heavenly vault, azimuth grid, different cosmological things. So if you want to put a Yggdrasil tree at the North Pole and postulate what it would be like to, if there was a giant tree at the center, you can indulge in some of that. You can put Mount Meru up there. You can put different toroidal vortexes here. This one's my favorite. Just different stuff you can do. If you're into the old turtle elephant cosmology,
if someone asks you what's below flat Earth, Flurf, you can be like, hold on, my model will show you precisely. It's turtles, bro. Don't be a fool.
It's turtles holding up elephants. So,
like obviously.
There's that. There's different map projections you could swap to here. I like this one because it's like designed to the coordinate system, so you can see kind of roughly where the latitude is corresponding to where we're familiar with. But yeah, you could look at different. Turn this off. In tracking, tracker, clear all, optical vault. Yeah, so anyway, different projections there for funsies, where you could just have it blank and just see what's going on with that. I like how it kept the central angle thing.
I don't know where I am, but I know how far I am from that other dot.
Yeah, exactly. Yeah, then there's the globe Earth variant here for this, so you can change different projections to see how all that works. Then there's, of course, the dual pole projection, which is seeing both hemispheres simultaneously. There's even a tripole here. So in this projection, the South Pole is split in two sides, and the North Pole up here. So we got a tripole. They're all representing the exact same thing.
They're all different God's eye views of whatever one sees right here, a hemisphere, right? From the observable hemisphere, those are all feasible models one may construct.
All anyone has ever seen is this. They've just looked around and seen this. And then they started mapping it out to time and linearizing it, and then they ended up with this.
It's such a tricky thing because I'm sitting here just like playing out like a battleships in my head. Like, let's say you're on one side of the Atlantic, I'm on the other side. We got ships and we're just like launching ballistics at each other. No, if you're a glober and I'm a flat earther, like neither really offers us any real edge over the other, does it necessarily? Does it?
Yeah. So, well, that's the point of the coordinate system, is that it's self-referential. Like the visual differences don't offer anyone any mutually exclusive claims because the visual aspect of it is just part of the projection. The actual distances and all that are always the same.
You couldn't think of like could you think of an edge that I might have knowing that it's actually not a globe, like you're not around there?
Oh yeah, you just use a rail gun and then don't arc up, dude.
No, not really, because you're going to be referencing the same coordinate system. So like, it's not like you're going to be like, oh, I'm at a closer distance. It's there. Everyone who would be like using it for like a tactical, purpose isn't going to make the mistake of thinking uh, that it would actually be a different distance. Like, how we've been told for years that, how would this distance like if you were actually about to do like some stuff, like you wouldn't that mistake wouldn't be that wouldn't be an issue at all.
Well, dude, they wouldn't be using world
immediately
maps at all.
Well, that too.
They'd be
But
they'd be using local stuff.
That's the
the
thing.
distance
This
is
is like
for that.
one of
Yeah,
our
no,
my bad. Yeah.
go ahead, dude.
I was just gonna say one of our regular trolls on Clubhouse. He's like this really famous, the guy who did like the Hotline Bling video for Drake, Director X. He used to always come touting this paper, it's from some type of telecommunication about like putting up towers and accounting for Earth curve. But when you look at it, it was really just topography. It wasn't fucking Earth curve. But as we're talking about that, I'm wondering if like doing RF propagation, maybe having a globe assumption might,
Oh,
mess you up.
so that's actually going to tie into Monday's null hypothesis, because we're going to be covering Battle of the Beams, which is horizontal radio propagation over a flat Earth versus a sphere, where there is a mutually exclusive outcome from that.
I think that's where a lot of the proof. I mean, a lot of some of the best proofs are going to come from in the near future.
Yeah, well, a lot of the best proofs are, where you're not using the coordinate system self-referentially. Like when the globe lads are like, "Oh, look, the sunset," therefore globe. It's like, did you reference the same coordinate system that you always been doing? Like, it's like, oh, this body is going to be in this position, therefore globe, and it's like, did you just reference the same thing over and over again? The observation alone can't tell you. Uh you need some other variable, some other component. Like with celestial theodolite, right? It's not just about, oh, we watched the star. It intersected with a terrestrial feature at a known distance and elevation relative to the observer that we can use for comparison, independent of the observer that exists, fictitiously at the center of Earth. Things like the radio wave propagation, where based on the geometry of a sphere, they've established that certain horizontal propagation over depending on the frequency is going to hit Earth curvature and then start propagating as a creeping wave. And as a creeping wave, it's going to lose this amount of field strength over distance as it continues into that shadow region where it's now on the other side of the curvature, so to speak, for its radio horizon. And so testing different frequencies and the use of them and stuff, like things like that, are actually what's going to to tell the difference between the geometry of the ground as described by the coordinate system self-referentially, or when you externally test it, versus when you externally test it. So
Do they make any claims on like having some sort of like really good mapping of the ionosphere and where exactly to point something to bounce it from New York boom off the ionosphere and then down to like China, or is it like and would that require sky assets if so, or could you naturally just do that perhaps?
Yeah, so they'll invoke whatever they need to get the propagation going. But for something like Battle of the Beam specifically, where it was horizontal propagation and not skywave bouncing or anything like that, like some types of signal sending are not going to result in like a mutually exclusive outcome, or could hypothetically be explained by, an ionosphere bouncing the signal back down and, creating a skip, creating skip zones to the target and stuff like that. There are things like that that they could use to explain. But what really separates the Battle of the Beams is that, it's a horizontal propagation that a plane had to fly through essentially to hear a specific tone. So there's not a lot of wiggle room for bouncing or anything like that.
Any globe objections to the model? Because there's always that, you guys don't have a model, you can't model anything. Where's your model flurf, etc. Where are
And
those
keep in
lats?
mind, like, conceptual model, we don't live on a model, right?
Yeah, nobody lives on a flattened out graticule either.
Extremely important disclaimer there, right? Is that like the big mistake is thinking that like we see some sort of God's eye view of this scenario, therefore the sun should be here for all converging to all these observers. If I'm standing here, like nobody sees that. This is like that mentality comes from seeing like this God's eye, or like trying to apply a God's eye view to it for a conceptual model. So just wanted to clarify that. Like all the
Yeah, I don't
heavens
think
that we're
some people
seeing
should be able to
exist
help
in
themselves
here.
reifying this and just seeing this as is too. I think they could be kind of hardwired to do.
Yeah, it's been really interesting seeing some of the arguments put forward where it's like you could tell that they truly didn't understand any of it at all, and like they're just locked into not being able to separate the coordinate system from the ground. It's gone
Yeah,
too deep.
all of the objections have been, look at the size of Australia, flurf. Like, okay, but did you look at any of the, like, you understand the principle behind? No, you care, but no. And then the other argument is, yeah, but you looked up and you marked the position of that body, and then that body gets represented in spherical coordinates, and that's the globe. You lose. So that's pretty much the entire globe position on this, is that if you look up the sky, you reference the sky, that's the globe. And then if you don't have a map, then your model is worthless. All we want is a flat Earth map. That's been the overwhelming response, to be honest.
It's like you want a map with latitude and longitude based off of change in position of the stars over a flat Earth. Done.
Yeah.
Chinese did that. What's next? And
Yeah.
then it's like, well, it was never actually about that. Still globe. It's like, okay.
Yeah. Yeah. It's like, well, no, you can't have that. So globe. Show me some Eclipse demos.
Oh yeah.
Do they go slow?
Yes, we got some Eclipse demos here. We can cycle. Actually, there's a button for eclipses. We can watch them natural in the wild. So there's a
Look
button
at that.
over here.
One just happened.
Where you can cycle. We can jump to the next eclipse that's occurring.
Oh, you just advance time until the next. Oh, that's cool.
Yeah. We could just watch it, and then so we'll pause it through one here. And we could see the umbra, penumbra, and all that shadow stuff is all
that's
calculated out through a bunch of stuff that Shane would probably like to elucidate on.
Move Nikki over into that band and then drop us into the view. Let's see it.
Yeah. That should work.
Run the figures, man.
Yeah, should work. Look at that. That's so nice.
You're living the experience now.
So as you move in the path of that width of that shadow, then the position of the sun and the moon will change. So that's the Baselian element prediction with the gradation there using the polynomial expression. So it's like a series of polynomials, and then you have x and y above the or below the fundamental plane, drain through the circle there. And then you do, a parabolic, so it could be squared or it could be cubed, and that would be the direction of the curve that the eclipse path is taking. And then you plot that on the good old graticule, and that's what gives you the path of the shadow. So the thing that they say is impossible without the globe just uses Baselian elements, which is derived from, you know, the positions of the stars and geocentric ephemeruses, and then they use the polynomial expression to plot it out on a fundamental plane using x and y as positive and left to go left and right, up and down. It's really easy.
With a side order of Rahu and Ketu.
We should have
Yeah.
put that in, but like made them look like unicorns or whatever, and been like, "What? You said they were
They're-
invisible."
Leapfrogs.
They are in here.
Really? You put them in?
Yeah, there's an eclipse.
How do we see?
Thing? Let me see if I can find it. Eclipse position.
Someone came in the room last week and mentioned that I don't know, I didn't check, but they said that NASA actually uses like these lunar nodes, and they call them Rahu and Ketu in the eclipse model.
Oh, I'm sure they thought those names up themselves.
That's more or less accurate, though. I mean, except when they said NASA, they meant Fred Espenak specifically, that one guy who recently died. That's what when they said NASA, they meant him. But yeah, otherwise it's accurate.
Oh, he's the guy
Rising-
on the Sorrow cycle and all that. Is that him?
Yeah, he's
That's
the
the
famous
boy.
guy. He published the 5,000 years of solar and lunar eclipses, and he's famous. He's called Mr. Eclipse. Used to run his website, manufactures and sells all the eclipse books. But he's like,
the name was familiar. Alan posted his geocentric ephemeris the other day, but I didn't really put the two and two. It was the same guy.
Yep. So he's got the best ephemeruses, and then NASA was like, "Listen, Fred, we need a heliocentric version of this," and he was like, "Why?" I'm paraphrasing. And then he finally did it and converted it for them. And then at the end of it, he has a quote that's like, you know, at the end of the day, it was 0.00001% accurate after running, you know, 10,000 JPL simulations for ellipticity. And he was pretty much saying, WTF, like, why did I waste my time on this? It makes literally no difference. And that was his contribution. But then NASA used him as the scapegoat. So, like, if ever there's a fault in the NASA prediction eclipse, actually, the disclaimer says, no, it's Fred's fault, not NASA. NASA takes no responsibility for the eclipses put forth. There's this giant disclaimer, and they put it all squarely on Fred.
That's hilarious. But like Bert, he was, you know, one of our optical engineers, used to be on NASA. He came in and was, you know, heavy-handed, saying that only a heliocentric ephemeris matches observation. And then Alan cat through the Espenak ephemeris in the chat, and then he just immediately, you know, before he even clicked it, I had kind of like yeah, well, there is like a mathematical transfer. Like, well, wait a minute, wouldn't it have had to be the other way around? Like, who the fuck made these observations from the sun and then changed it? Like, we made it would have had the other way around. Like,
yeah, like how useful is a list of observations from a place no one's ever been? Like, what do you think you're gonna do with that? Like, hold on. Like, it turns out every ephemeris ever is geocentric, except for a very few. The vast, wide majority of all ephemerises are geocentric and always have been.
I got some anecdotal.
Mental block. You couldn't get him to say just logically, like, yes, that actually, yes, logically,
Yeah.
would have to. Just couldn't. It was like, nope.
Just,
Like,
dude,
what?
they don't want to do it. They don't want to give you
dude,
anything.
The actual position is, sure, that's true, but with, you know, heliocentrism and gravity and Newton's laws and mass attracting mass and JPL simulating these factors for a bajillion epicycles, we can actually increase the accuracy of that threshold to a degree that proves our model. That's the actual position, but no Glober says that. It's like, okay, because when you get down to it, it's like, well, how much did you improve it? By a factor of what? How many arc seconds? What? Who gives a fuck is the answer.
Yeah, but this is big, man. I can't understand how big this is because, and like, that's what I was trying to get at earlier. How far up, or like, how concerned are you even? I guess you just maybe just making and let it do what it does, but like, how concerned are you with pushing this up the ladder, like the academia up in the ivory towers, and like, and how, you know, have you spoken to any, like, I don't call them bigwigs or whatever, but you know, any academic types that are like actively in academia?
No,
Any interest in it?
none.
I mean, it just to anyone who gets what this is and what it means, it's very, very speaks loudly, you know, to the point that
Dude, there's probably some market to sell a Ptolemaic epicycle astronomy mobile app somewhere. Not gonna lie. Somebody wants that.
Was saying sell
Well,
this leash shit to China and they can use flat Earth, like we could drop the flat Earth bomb and fuck your whole society up. So it could be like a whole
Dude, you could
geopolitical.
disguise it as like an epicycle calculator and then like just sneak into like flat Earth, like make the globe the default mode, but leave all the flat Earth stuff in and wait for someone to download it and just like change the map and be like, what is this? What do you mean it's all the same? Why is this map different? What is this shit? What did I buy?
just do an update
I
one
mean,
day and switch it
yeah.
to flat Earth mode.
Yeah, well, like you, because it's already got like 17 languages in it, right? So if you made an app and just put it out there, somebody would figure it out, and then it would become like a secret flat Earth app that got out there under the astronomy guys or whatever. It's like, no, it's just a Ptolemaic epicycle calculator. What do you mean flat? It's got nothing to do. What do you mean? It's just science, bro.
Hilarious.
Yeah, I don't know, man. I feel like he's being way too fucking Taoist and like pacifist with this. It's like you need to bust your gun. You need to start flaming as if we flaming people with
Dude,
this shit.
we've been throwing it on Facebook and throwing it on Twitter, and I've been running comment trains on the people trying to object. And what I gave you earlier is by far the vast majority of all scientific, rigorous code lad objections. Is if you look up its globe and where's your map flurf. That has been the only objection to this model being put forth. So not actually more than a couple globers have been like, hats off, cheers. This is actually really cool and visually striking. Before they're like, but Earth's not flat, so dummy or whatever, right? But they'll give you the preface of actually, this is really well put together. It does a lot of cool things. It really looks cool. But tis globe. That's what a couple nice globers said on Facebook. But mostly the response has been, nah. You can't look up and where's your map? So that'll tell you everything.
Yeah.
Yeah, man,
No,
for
that's
years, like a battle this shit on Clubhouse with mostly just rhetoric, right? A bit like a sort of a cursory understanding of the math. I was really listening to you guys. I kind of really got a much better like epistemic understanding of what all of this shit means and from whence it came. But like now it's like you really see like one of the main
see
things
it.
before was like,
It's
even rhetorically talking. Why do they always have to argue the globe from the sky? It's like something I would always point out. Like notice that one side will incessantly crank your head up to the sky. Like it's the only thing they'll talk about.
yeah. It
That's
was
where
it was derived from the sky entirely. There's no place to go other than referencing the sky for them. Just solely based on the observation too. Not even doing any sort of like
Yeah, but
independence.
to be fair, dude, like through all of our research, I found out that all their models and dependency and accuracy depends so little on the Earth actually being curved that it doesn't matter. Doesn't matter at all. For any of the modeling for WGS84 to work, like it doesn't matter. So that's why, like, no, we'll never be able to challenge that. We're never gonna get someone to not use WGS84, right? They're gonna be like, okay, but did you verify the length of that meridian arc that wasn't internally consistent by referencing your geodetic latitude by measuring a small amount? They're like, yeah, who gives a shit? Like, it's accurate. It's accurate. We know it's accurate. It's accurate. But the truth is, if you were to measure that, you wouldn't even be able to differentiate on that small plane measuring that distance if the Earth was curving or not at the prescribed rate. So like it's all moot. Like the whole model is gonna work. It's all based on angles for the stars. You confirm it by looking up. You always know where you are by looking up. They solidified the hell out of that. So it's a really well solidified model that like it works. It definitely works. who thinks
But Shane,
work?
what about those gravity corrections they make?
I was just about to ask about that. Like, what's the relationship between like the trig and what's actually
No, you should check their orders of magnitude. It's embarrassing.
some tiny shit?
Yeah, so the difference in position they get out of that is arc seconds. It's like an indistinguishable amount that you wouldn't be able to really reference terrestrially.
Oh, so that's weird.
Certainly not with that optical instrument.
Yeah.
Yeah, that's like the margin of error for like the instrument is greater than that.
Yeah, it ends up going from a measurement to like a calculated refinement of the measurement to try and get any meaning out of it in terms of like that level of accuracy. But yeah, it took the whole the whole thing and just modeled it all out and showed all the things that we've been talking about. And then, like you were saying, to see it start from a unit sphere and then just be angles in time and then turn into an internally consistent ratio of distance on the ground to angle change in the sky, with the Chinese stuff, and then converting that into familiar meter units. It was just like, oh, it was exactly how we said it was.
Yeah, it was refreshing. Oh, well, dude, we're exactly right. Look.
Remember the lore around like Bislin doing it at first. I heard that he was kind of surprised at how hard it was to debunk as he was, that things were kind of working out surprisingly. You guys just took it a lot further.
Yeah, that's why he added the bendy light to stars that aren't even being observed by the observer to just make it look as retarded as possible. Because it is when it looks like this, you're like, oh, that's reasonable.
Have they hit you with bendy light yet for this one?
I mean,
Yeah, he invented bendy light. Like, nah, it won't work because look at what you'll need. Hold on, let me add what I think you'll need to make it work. And now look how ridiculous that is. See, because you need all this bendy light. It's like, what?
No, but for this model, has any Globus hit you with like, oh, you need bendy light? Or is there any way to fit that in?
Yeah, they'll be like, this model was made by Walter Bislin. You're a thief. It says that, like, he's only credited for the visual style and only like as a courtesy. It has nothing to do with it. Nothing remains at this point. There's less than like 2% similarity with what it was. So I don't understand. I don't understand the people that make that claim. But like I said, they're making you can't look up and where's your map claims as well.
Doth thou look up, my lord? So
it's tough to get them to say that's what they're saying. Like they're not going to say that the globe owns all observations of the sky, but everything they claim assumes that, and it's frustrating.
This reminded me of that movie "Don't Look Up" with Leonardo DiCaprio. That scene always
that's kind of fun.
The scene where he's like so much math, and like the train door is closing on. He's like, it's all math, and like winked at him, and the train door closing.
Yeah, something I wanted to show real quick was something that was coming up during the celestial theodolite was why the globe predicts an earlier timing for the geometric intersection, and that's shown here. You can see there's a refraction mode that you can enable, and so when you turn this on, you get this position here, which is the apparent position at the time, and then you get this circle here, and the circumference of it intersects with where the true position is. And as the elevation gets closer to the horizon, the circle gets bigger because more refraction. So you could see the angular difference in position between true position and apparent position, and why they would predict the earlier timing, because they're always referencing a lower angle to that fictitious observer at the center, which gives them the ability to say like, oh, well, my horizon's actually a tangent on a sphere. It's like, okay, if that's the case, then your star elevation should be lower because you're, on a sphere and you're looking off at an angle. Like, so that's, what this, hopefully when we get to the null hypothesis celestial theodolite version, we can get the globe lads to kind of see why it is they predict that earlier timing.
I suspect there will be difficulty in conveying that specific concept.
It's like, okay, but wait, Shane, what if we go to the center of ball though? Like, what if we look at it
from the fictitious? Yeah, now it makes sense. Listen, that's my model right there. Look, see it from the center? Yeah.
It's like, oh, dude, it's still lower. Shoot. Oh, indubitably. This
is such a ridiculous amount of work to show this, dude. I can't believe you added a celestial theodolite extension to the model for this.
As you said they put this together, this feature.
What's that?
You specifically, you personally put this feature in there?
Yeah, because nobody they were arguing against it so hard that the globe, like why they predicted an earlier timing, that it was just like, do you see it now? Because like when we do it in Stellarium, when we do it on a write-up, they all are like, no, but like you can see it here visually now in real time. So,
well, we had like Desmos demos in math before.
So as it gets lower to the horizon, actual refract like you have the refractive tables built in, and the circle will get bigger, and it'll
What does that radius represent?
Represents the angular difference between the true position and the apparent position. So like however much refraction there is, it's an arc-second difference as a radius. Just to kind of, just to
Oh, I
show
see.
the,
So the whole path is drawn, but it's expected to its arc of travel. I get
yes.
it. Okay.
Yep. And so let's see here. So yeah, the formulas that they use for refraction are dictated by what degree of elevation you're looking at it off the horizon. So
Oh yeah, for sure.
uh,
I caught that right away. That's the
so
supreme influence.
yeah, so yeah, we just incorporated the Settlement formula and the GG Bennett formula. I found that this Settlement formula is closer to what Stellarium predicts at the horizon, like almost to the arc second. So uh, I typically go with this one. But yeah, then you could adjust your temperature and pressure, and then it'll fine tune it. But yeah, this is basically what Stellarium would show you if you hopped in, went to this latitude with the default settings for atmosphere, and watched it set into the horizon. You would see, this amount of refraction would be plotted out exactly.
Where's the
you
value
get that
listed?
apparent and geometric from the God's eye view? Can you see that circle from another perspective?
Yeah, 1 second. Oh yeah, so it's over here. Yep. So it's showing more than what needs to be tracked. 1 second. We need, if we do Theo, turn all these off, and then just have a query eye on. There we go. So yeah, right here, you can see it. Can try and zoom in a little bit. Where's Denby's?
So back to the chart for a sec on the left. That means the Seidelian refractive radius would be 13.43 minutes. Is that what that means?
Yeah.
Okay.
Yeah, it's just however much refraction there is between them, and then a circle's drawn. So you can see it. And if we do permanent nighttime, you can see. Huh. All right. Well, in any case, that's for that as
15
well.
minutes at 3 to 2.5 degrees above, almost 3 degrees above the horizon. That's 15-ish minutes of radius. Okay.
Yep. Yep. Yeah, if I tuned the temperature and pressure to what it was at Mike's, it would go down to 13 there, and it would be exactly what it was, or calculated to be,
Yeah,
to match
just under a
Stellarium.
quarter of a degree. That's what we're really talking about.
Mm-hmm. All right. But yeah, everything's there. We got different demos, which we already went over. Let's see, Sigma Octantis from 3 different points. Let's see. Why is it oh, because it's sideways. That makes sense.
How satisfied are you with this right now? Like, how complete do you think this is in accomplishing
Oh,
what
I was I was super satisfied with where it's at. A couple of bug fixes and stuff need done, but just stuff that's whatever. And then somebody hit me up with some suggestions to add the magnetic declination stuff and a couple other things that seemed really cool. But basically, everything has done. There is another gentleman who forked this project on their GitHub, and he added like Michelson Morley, Aries failure, all kinds of different of the interferometry experiments that were done. And so you could see like an ether wind drift vector over the ground and stuff. So there's that. We're gonna, once he gets everything more refined, I'm gonna merge his stuff with mine. So you'll be able to see like you'll be able to like go to different latitudes and then pull up the interferometer experiment that was done there and see the readings and that kind of stuff. I think that'll be an awesome addition. Yeah. Yeah, but everything's more or less done. I might get some wind current stuff from like, the Bob's Wind website or something. If I can import some like real world data,
might as well do the
that
whole
would
Bob's
be,
Wind thing. Yep.
yeah, that would be super dope to do now that I just said that out loud and like I'm like now I
I
have to do
immediately
it.
was like, oh, we had definitely doing that. Yep.
It's like, yeah, I gotta do that now. But yeah, there's been some suggestions and stuff. If you guys think of anything cool, just send me a tag here on Discord or tell Kat and she will relay it to me and
Do you
I'll
think
add
you
it.
could get this thing to do my taxes?
I mean, dude, Nikki's been studying hard to get her CPA. I'm pretty sure she could do it.
Like equi-projectional taxes?
Ecuador rules. Who knows, dude?
Are there even taxes in your country?
Like, what does that even mean to you?
Speaking of Ecuador, can you let me get like a Nikki view of the like those star trails you see where it's like going kind of split down a little?
Too hot to look at that down there, man.
Absolutely. So we can go 0, 0, and then we'll look east and hop in Nikki. Hop in the Nikki view. There we go. And tracking east. And play stars. Hang on a second, it's offset. There we go.
Dropping some hard R's. Control Shift R's.
East, then grid. Volt grid, optical volt grid. There we go. Then there we go. So we're at the equator, we're looking east. You can see stars and whatnot rising.
Well, that looks like the Rob Stellarium.
Yeah, the ones that are closer to the side here, you can see they're converging or diverging out to the left and right respectively. And then the ones that are closer to the center are more or less, staying within that band. But yeah, there we go.
What about the when you're done with that, the Sigma octane, like the Southern?
Yep. So, that's the wrong one.
Have you put in the switch to invert the drag mouse direction yet?
No, I have a list of stuff. I haven't fucked with this one at all, and
that's on the bottom. To be honest,
oh man, seriously,
bro, I worked on it for 2 weeks straight, and then I took a break, and I haven't touched it since. I needed a break. But yeah, here's the Southern Cross, and it's always pointing towards Sigma Octantis here, which is right here. So we're at the equator. So let me go south a little bit further, and then we can see it there. So Southern Cross here, pointing towards Sigma Octani here, and we can see all the tracking information here for it. It's like, oh, dude, Alan, did you make a tracker thing like Stellarium does when you click on a star? Sure did, bud. Sure did.
Yeah, and you can see that Sigma is nearly 2 degrees off of 180 at this point even. Like, it's not really the Southern Star, but it'll do. Not that people can actually see it.
It'll do. Oh, actually, on that note, Stone, thank you for bringing that up. Actually, what the Chinese did to reference a fixed South Pole was they took this star here that leads the Southern Cross because it always points in this direction, and they would just reference that as a position in the sky hypothetically for a
Yep,
for a thing.
just like a hand on a clock.
Yes, sir. Yes, sir. So yeah, So we could play this out here.
Interesting
rotating.
coincidence there, hey?
Mm-hmm.
That's
we have a
crazy.
demo.
That's the globe.
And then, and then we have a demo here for 3 observers seeing, because there's that. How do the 3 observers see a signal octanus from different locations or whatever? I don't know if you've ever seen that, but we have it here.
Oh, you can see it swinging around nice and wide right now.
Signal.
I think they're looking at the Southern Cross.
So
No, I was watching Octantis there with its 2+ degree radius around south.
Yeah, but I think one of the anti-flat Earth claims that people address is the observation of the Southern Cross. Actually, on that note, what was Globy McGlobe's faced observation if it wasn't that?
This.
Did you find out when you what?
Yeah.
Was it Sigma?
It was
so it was.
Yeah, it was just the
Was it part of the
Octantis
crux?
thing.
Oh, okay.
Did you guys already see CM's PTR about this?
Yeah, I was literally
Never
about to
had
read
it.
it out loud. It says the solar eclipse demo made zero geometric sense. They didn't even attempt to demonstrate lunar eclipses, flat Earth model.
Well, that was the solar. That's how we looked at it specifically. But
He
yeah,
just put words over a screenshot and thinks he's fancy.
There should be a lunar one here.
Yeah, I
Let's
literally
see,
had
too.
Ellen change the perspective to on the ground watching a solar wind going by as it was setting. Like literally, that's what we watched. So I don't know what that guy's talking about.
In demo.
I mean, we got the full-on Nikki experience of the eclipse.
In
You know.
tracking.
with the nice explanation of predicting a shadow path using Besselian elements of fundamental plane, X and Y,
right
some
across the
polynomials.
surface. It was real.
Yeah.
Clear all, and then celestial.
I think you have to be so bad.
She's just getting to the truth, man. You can't stop her.
True pause. There we go. So yeah, you can go to.
I hope she can swim.
You can skip to different lunar eclipses and see. Oops, pause. Like they're on there, and what you'd be looking. Wow, God, why is it not showing? There we go. So yeah, what you'd be looking there is like, oh, how does it create? Without the Earth being in the center. Well, have you met my friend Yggdrasil?
The big ass tree.
I'm
So
not
lunar
saying that.
eclipses-
I'm not saying that's what causes the eclipse, but I'm not saying that there's not a giant tree in the middle.
lunar eclipses always occur when the sun and the moon are antipodal, when they're the farthest point away from each other, right? And then you get the red occultation from the full moon, right? So when you get the crazy red eclipse, and then it always occults from a 45-degree opposite rotation from the direction that Earth's motion is said to go in. So I don't know how you can get like a red lunar eclipse, obscuring from left to right and then unobscuring from like bottom to top. Like, how does that work if the uniform motion of a spherical Earth is actually causing that? I never thought that was a good explanation.
It leaves out at a different direction, like in a kind of different path.
Yeah. Yep, it looks very weird to me. I looked at a bunch of them, and it doesn't make any sense that a uniform rotating sphere, like as it would go by, actually, it looks like it changes direction halfway.
Yeah, I've seen that actually. Yeah, I've seen like a time lapse when it's sped up.
So we know that the moon and the sun are antipodal, and then we can speculate as to what's causing, the red glow and the actual occultation of the moon separately. But the model will show exactly where you'll see one.
So for the God's eye view globe version, everything's right here. They say that the terrestrial sphere would be the cause of the eclipse or whatever. And then looking at it from dual pole, same scenario. They're, like Shane was saying, they're 180 degrees opposite of one another. It will tripole, and then for flat Earth. So our assertion is, we don't know what's going on up in the sky. All we perceive is what's going on in this dome here. What's up here and what the dynamic cause of a lunar eclipse is, couldn't tell you. But like Shane was saying, there are things modeled out with like the Salanillion where the shadow comes from the opposite side of what's predicted, stuff like that. Um, it can't be said for certain then that it's absolutely, due to Earth being the causal mechanism of it. But obviously from this perspective, it's like, oh, well, yeah, we could just throw that in the middle there, boom, there we're and done. But yeah, to say that it doesn't make sense or that it was misrepresented is like, I don't think that dude's paying attention. It's literally the same thing on all different projections.
Nice. So yeah, everyone should go play with it. Everyone should go try and break it, and the Globers should use their AI tools and scrape the code and show us where it's globe related or whatever. How you need a globe to use it. Angular inputs, right ascension declination.
It'll definitely tell you how it has to be a globe or whatever, but it won't find anything in the code that references it specifically.
No, I know. I've tried it. I know exactly what it'll tell people, dude. It's not. I didn't think to do the thing that I'm asking you to do. That's crazy.
Yeah, man, it's fire stuff, man. It's vindicating as hell, and I feel a little bit more, not a little bit, a lot more secure in my, my pleasureism.
Same. It was very
Flurfism.
Yeah, it was very relieving to see the ratio consistency stuff arguments play out exactly how we said they would. And it was very like, oh, nice. Ooh, it didn't lead to any crazy discrepancies or whatever.
Well, because we were leaning that way, like arbitrarily, we were like, well, the constants just must be like ratios, and then we made that argument, and then we found this quote from this guy from JPL who pretty much said the exact same thing. Here it is, right? I think I found it here. It's from JPL Laboratory, California, from 2003. He was like, hey guys, all of our constants, they seem to be inextricably linked, and they're not independently verified even today. Should we do something about that? And they were like, nah, and then no one ever did. This one honest guy called it out.
Nah, and then no one ever did.
And then that's also evidence.
Self-reliant circling. No problem. Reification just all built in. It's all consistent because it is consistent.
So one guy noticed the same thing, and that's what we put it in the model, and that's what if you look at the model and you take out all the constants and you're left with just ratios, and you're like, oh, it doesn't break, it works exactly the same. Oh, that guy at JPL was right. Yeah, what does he actually say? He says, the fundamental constants of Earth consisting of elements of its orbit, the mass, constant specifying size, shape, orientation, rotation, inner constitution, and the velocity of light all comprise a system of astronomical constants. And this group of constants has been called a system because it comprises a model of the Earth and its motions. The interpretation of all astronomical observations depends on this particular model. Furthermore, because of the many theoretical relationships involving several of the fundamental constants, some of the constants are necessarily systemically related. And he says Dr. Sitter wrote in 1938, an ideal system of fundamental constants would be one in which these theoretical relations were satisfied rigorously, while the adopted value of each individual constant agreed with its observed value within the limits of uncertainty of the latter, and that this ideal has not been realized even today. And it's like, oh, that's pretty much what we were saying, is that they're all not independently derived, they're interconnected and dependent on each other as proportionate ratios. And that's all the system of constants really is. And when you take them out of the model, nothing breaks, everything works the same. So it doesn't matter if the sun is 1 or 93 million or how you get an AU. It's just what they call as an AU is unit of 1, and then everything scales from there, as we've been saying.
I unmuted on the wrong platform, but I was saying, I was talking on Clubhouse saying, when you think of whether it's unfortunate or whether it's insidious, whether there's like a cabal who's knowingly. Just the fact that so many of the best and brightest, like fucking probably millions by now or thousands, the best and brightest have been conscripted to just do fucking insane busy works around fake dynamics or imagined dynamics and just making this whole big fucking paracosm, this big old
Welcome to
imaginary
CERN.
shit.
Well, dude, you remember when we did the for the stuff for the prediction of Artemis, and they were like, "Look, we have dynamies," and you were like, "No, it's just kinematics," meaning all the trajectory projections, all the mathematical like they use G and GM, and they pretend to use mass, but it's really just a kinematic equivalent of period and time anyway. And when they're all like interchangeable. They pretty much just swapped them out algebraically, and they're like, "Look, we're predicting using mass," and it's absolutely not. It's never that. And that's the trick that they've been doing for a long time. Ever since Newton came along and said, "Look, I can describe the same thing as Kepler, but I can do it because mass attracts mass and there's gravity."
Yeah, so it's gotta be caught knowingly selling snake oil.
I mean, at some point, they definitely were like, hey, let's just say that this is how it is and teach everyone the spherical doctrine. Like, I found this book from forever ago, and it's basically the premise of the book is this guy in like the 1600s went to different countries and asked them about their cosmology and like basically, their capabilities. Like, do you guys cook? Do you guys, what do you guys do? And so anyway, when he got to the British part of it, he talks about how, oh, the Brits came up with this thing called like the spherical doctrine, and it's this two-sphere method of navigating. See if I can find it real quick. Um, um, but yeah, it's like what like go ahead.
Sphere's your model.
An
What's that?
astrolabe has been around for a while.
Oh, that's
And the
interesting.
armillary sphere, and yeah, for sure.
Yeah, the Chinese actually had like a sidereal armillary sphere, not an equatorial one, or the one that like tells you the position of the sun throughout the year. They had the
The
sidereal one that tells
giant
you the
helmets.
positions of the bodies throughout the day. Let's see, where's your model? Is it this one? Yeah, right here. So the universal geographical grammar, wherein a situation and to the extent of several countries are laid out according to the most exact geographical observations in the history of all the different kingdoms in the world, is intersped such as a manner to render the study of geography both useful and entertaining. 1777, same year as the royal decree that came out, basically saying that if you were using a different coordinate system than latitude and longitude as defined by the king, then you were going to get taxed basically and put into financial destitute. um, but anyway, when you go through this, there's a section here on the doctrine of the sphere, and it says about the celestial sphere and mapping the positions of the bodies to that fictitious observer, creating that hollowed shell sphere situation that we looked at earlier. So this is like one of the earliest references I could find to them talking about it. But like, yeah, the king made this a royal dictate, and since 1777, nothing's been the same. Here's no, that's not. Yeah, here's the decree right here from one of the almanacs of the Parliament of Great Britain, extracted the act of concerning longitude during the 5th year of His present Majesty, printed by the Commission of Longitude, 1776. So in here's the royal decree and the fines to be imposed, and then also a reward for anyone who could improve the system and make it better.
So, what's crazy? I just thought of, and I saw that armillary sphere. We all kind of get indoctrinated. I mean, we all kind of see the images of Atlas holding up a globe, but in the mythos, he was holding up the sky, and that's like in a lot of the old artwork, he was holding up like an armillary sphere. It's crazy how they just interchange to the sky.
That's a really good point. That's crazy.
I've heard that.
Well, it used to be called cosmography, right? That's what they called the whole mapping of the world, and that was inextricably linking the ground with the sky because they knew the importance of the stars and mapping out the Earth. And then only in modernity they're like, oh no, we're gonna split it to cosmology and cartography, and we're gonna do different things. Ignore the whole field of astrogeodetics, and we're gonna combine those two anyway. But cosmography is old, ancient, and goofy, and now we have cosmology and geography. But if you read Geographia by Ptolemy, literally putting forth the two-sphere model will tell you exactly where all that came from.
Yeah, dude, the Chinese were making crazy armillary spheres back in the day.
Yeah, it's like a 3D astrolabe, but like less complicated. Actually, I think an astrolabe probably has more predictive power than an armillary sphere, but they're definitely woven, interconnected circles. Dude, an astrolabe is super cool. I put a link in the chat. I think it's a GeoGebra model where it goes through like all the different things that it can do with it: eclipse cycles, predictions, ecliptics, where the sun is, every star, latitude dependencies, altitude of the sun, all zodiac circles. All sorts of crazy stuff you can do with an astrolabe.
It's awesome. Thought I had some good armillary sphere pictures.
One
But
of the dankest quotes is this Copernicus quote where he says, "So far as hypotheses are concerned, let no one expect anything certain from astronomy which cannot furnish it. Lest he accept as truth ideas conceived for another purpose and depart from this study a greater fool than when he entered it." I mean, holy shit, coming from Eddie heliocentric.
Dude, that's one of my favorites.
That's a good one.
He told us exactly what it is. It's like, it's a
Was that
conceptual
Newton or
model,
Kepler?
boys. Relax. That was Copernicus.
Righto. And we're looking
He
right
was
at
like,
it, dude.
He was like, boys, please don't kill me for this blasphemous teaching tool. It's just a conceptual model for funsies. And everyone was like, all right, but I'm watching you. And then 200 years later, the king was like, guys, I'm pretty sure he meant it was an actual model and it's real.
And then, like I said, conscript some of the hella mathematicians to calculate just how fast we're free falling around the sun. And that's 93 million miles. That's fucking insane.
Well, that wasn't until Michelson Morley, right? Right then everything. The Earth was orbiting the sun. That was easy until you couldn't measure it. Whoops. Okay, now it's definitely not rotating. We're actually free falling in a geodesic arc through the curvature and bending and warping of space time, which is safely undetectable by linear motion and interferometry. You're welcome.
Dude, I forgot about.
Dude, is this Spider-Man? Why is he in this
No,
presentation?
that's Blitz snorting the sun.
That's Kepler.
Oh my god.
Dude, I forgot I made that.
Crazy fucking quote too. You ever heard that? It was in there was a quote I read in Heliosorcery. He was saying something like, "As I sit in my study, I feel nothing can stop me." It was just crazy. This shit sounded crazy. He's like, fine. He's like, "We'll rewrite the scrolls of the Egyptians. This time I write the book. This time we." This shit was crazy. I was like, "What the fuck?"
Dude, he's the king of the universe. Yeah, that's hilarious. Have you ever seen Death Note?
I'm familiar with the
Oh, are you familiar with the chip scene? I feel like there's an analogy there with the chip scene. All right, well, no worries. I'll add a Death Note simulation to the model too, so we can all enjoy that reference.
Was that an anime reference that nobody cared about?
It
what
was.
happened?
It was,
Okay.
dude. Yeah, I mean, you say nobody cared about it, but to the 3 people that are listening that watch Death Note, they're gonna be like, "Oh, I know the chip scene. That's hilarious."
I knew what it was, but I don't care, and I wanted you to feel it, so I just remained silent.
Wait, dude! What? Dude, you took the chip scene?
Someone was telling me about some anime. I think it might be on Netflix, and it's all about heliocentrism, like kind of freeing. It was crazy. I was like, "Fine." Is Linnell in? That was the one telling me about it. And it's like, it takes you back to old China, and it's like this occult guy kind of showing this guy the secret of heliocentrism is like this little symbol thing, and it's like it's fucking crazy. I gotta find it.
That
All
sounds
about pretty
awesome.
much kind of like how Three Body Problem had, like, the Chinese they were being oppressed because they couldn't get these new scientific Western ideas, but it was pretty much the same thing in the anime.
Oh, dude, there's no way. I didn't watch Three Body Problem. Is that what it was? Is that what it was about?
No,
Yeah,
it was really
yeah.
good. It wasn't about that. No.
No, there was a part, no, that was the anime, but there is a part
Yeah.
in probably they take you back to, like, I guess the revolution in China, and people are being persecuted for any of the Western cosmology ideas.
Oh, wow. Yeah, I think it was the opposite. They persecuted people who didn't believe in it. Dude. Like in Japan, they got the emperor to outlaw flat earth geocentrism, and you had to be a geocentric glober for a number of years, and then they finally lifted the ban.
Yeah, dude, heliosorcery is a really good reminder of how all the history actually was to be like, what are these people doing? Well, they have a philosophy, and through external reach in the world of society and lots of decades, they've extended that philosophy into your science. And now you think science is their philosophy, and that's through design. It's like, that's how that happened.
Yeah, well played, honestly.
Right? Like, who's playing the 400-year game? Like, they were.
What is the play, though? What is the play? Now with this in hand, with all of the whole who, what, where, when, and why, the whole crime scene in front of us, what the fuck? What's the play, though? What's the game theory? What happens?
Dude, they can do what they're doing right now. Like, they have the whole world by the balls. Are you kidding me? Everyone turns to them for truth all the time. They control every, like, are you kidding me? It's beautiful. The globe is the best tool for trying to control people. I think I've come to realize this. Like, you actually get a whole bunch of people to not only not trust their eyes, ears, senses. They don't think they're smart enough to understand science. They don't know what math is. They don't know what health is. They don't know what a man is. They don't know what a woman is. You gotta tell me what the truth is. Where's my expert? Just give me a white coat. Who controls that? Oh, authority. So they own, like, what everyone, like, sees and hears, and, like, so, like, if you can get them to distrust everything that they see and smell, like, obviously, don't worry, the government will tell you the truth. Like, those people are so easy to control versus the antithesis of that, who just actively disregard everything the government says for the suspicious attitude. They obviously, you're trying to kill me or whatever it is, right? Like, or whatever the opposite of just wildly accepting everything that they say is. They're like, no, get the fuck off my property, right? Like, so obviously that group of people isn't easy to control. And if you're going to control the world, you want a world full of the former, not the latter, or whatever.
They put it in that fucking Disney movie. I can't remember the name of it, but, like, the wizard was teaching the little boy. He's like, first we got to get rid of these old ideas, and, like, crushed up the flat Earth and gave him a globe. And I was like, you can't teach the boy Earth's round. You won't know his head from his foot.
It's like, aha, by design. Yeah, that's pretty good. Yeah, dude, when people are like, oh, I don't understand what difference does it make, it's like, it's the root of everything, honestly. We don't really get that point across very often, but, like, as you said, the control thing is, if you're going to control a bunch of people, you got to get them to distrust everything that they see. And, like, dude, it's in 1984, it's in all the good old lore. It's like, oh, the state controls everything. Like, what's true? I'll tell you what's true. The Ministry of Truth knows what's true. That's what's true. And then, meanwhile, you just contextually redo history and tell everyone what really happened. And that's what they've been doing to us, dude. Like, the winner tells every history book. So that's like, oh, what happened in World War II? Whatever the opposite of what you were told. That's probably what happened.
My little spiel is the same shit, man. It's literally it to me. That's on the money, because I say in warfare, like Sun Tzu says, war is deception. Any lie I could convince you of, I could leverage it, and if I could sit up lie right at the fucking center of what you think reality even is, that's a lot of fucking leverage.
Yeah. Anyway, where's our globe lads about our model? Corey, you think you had a good Coffee had questions. He was like, but how does everything in the universe work or something? I think that was his actual question.
Yeah, he's at work, fortunately.
Oh, I think he was going to be like, yeah, but what keeps the sun up there? We don't know. Nobody knows.
All the lore they have around have so much lore around, like you said, someone brought up CERN, and then what's the other one with the long L-shape shit? We
The
do the
Large Hadron
we
Collider,
not
the
that one. There's an
CERN.
L-shaped one.
The very
Oh,
long
oh,
interferometer.
LIGO. LIGO.
LIGO. They got law around gravitational waves, so they got all this dubious fake ass science that they think they really captured so much shit they understand, and they not really let go of that.
But dude, their equipment is so sensitive. Like they got big tanks of water and shit with bulb detectors all the way around it. Oh, for sure.
All right. Well, I think we're gonna wrap up here. If do you have any other questions, or does anyone else have any questions?
Yeah, I gotta ask you one more time, man. Why not fucking blast this into like academia in some formal, or write some angry letters, and maybe try to mask the. I guess you can't mask the flat Earth. No, I just feel like this shit needs to be super duper viral somehow.
I'm just swayed.
Add dollars behind the shit on some meta or something.
So I've seen like enough things that like refute relativity theory and stuff that won't get published. Like, there's no way that this is gonna go anywhere or get any traction. Like, I just
Not that they would like it would get introduced as canon in academia, but that you might
like
create some whistleblowers, you know?
I don't know, man. Like, whenever I think about that kind of stuff, I recall this guy who has a master's degree in astronomy, and he was battling the what's it called? The what's that global warm? Yeah, he was battling the global warming narrative, and he pointed out that the model that they're using for global warming uses a quote unquote flat earth model where the sun hits 100% of the earth at all times, and then they also get into this other effect where they're basically like recycling uh the greenhouse effect, which isn't what happens. Otherwise the greenhouse would just get infinitely hot, but that's not what's observed. So anyway, they do these two violations, and so this guy who's academically accredited, understands the math and model, was going against them on the news and wrote a book and stuff about it. They smeared that guy so bad, and just because he pointed out that they were using a flat earth model, the mainstream media just had to call him a flat earther. They just said this guy's a flat earther and he's trying to
Nah,
critique our model. They just gaslit the hell out of him and basically, ruined his career. And
that's crazy. So that's funny. Wait a minute. So they're using like a flat earth straw man where the sun lights up everything all the time to do the math.
yeah, yeah, I'll link you the guy's YouTube channel, because he actually did like quite a bit of research and work on it and stuff. But yeah, like the big refutation that the mainstream did to him was just to gaslight him and call him a flat earther. They never had to reply to him. They never had to make a new model. They never had to correct anything or retract anything. They just said this guy's a flat earther and he's trying to critique us. What a joke.
Ooh, idea.
Splendid
Might
ad hom.
hear some seismology shit onto this if it's possible. Bob Winds doesn't have any like waves and from like earthquakes in the ocean or anything like that.
I imagine
PNS
I could add
waves.
it.
And that's sweet.
Yeah, climate of sophistry.
Yeah.
Here we go. This dude's channel is pretty awesome. Especially if you're into the global warming stuff, he just does a bunch of presentations just debunking it to infinity. And but yeah, I came across this guy, and he was pointing out that model, and then they just started calling him a flat earther, and that's it. And nobody ever had to correct anything or explain why they're using a fake fucking model or anything like that to push a narrative. They never had to address it. So like seeing that, like I know that there's nothing I'll ever be able to do or publish that will ever have any meaningful traction, and it's gonna be for people that find it on their own, who are like looking for it. You know what I mean? Like I've kind of accepted that. But these are tools for a generation I'll never see.
Nice. Maybe we should supply it somewhere more permanent than your GitHub.
GitHub's free. Do you have anywhere that's
Yeah.
free?
I
So here's the thing. The
mean,
budget for the hosting is free and permanent, so-called.
yeah. Like if you
So
die tomorrow, then the whole world. No, it's fine. I guess your GitHub will last for a little
no,
while.
you could just fork it though, and it lives on through
I
whoever
guess.
forked it. Everyone
Yeah,
could make
you
GitHub
just
accounts
local
and fork
copy
it and have it
Yeah,
forever. So it's
that's
all
true.
good.
That's true.
So, bro,
Design
you're
permanence.
the new king of flat earth. Gotta wear that crown.
Dude.
No, they would just hit up Claude later. Hey man, you know that thing you made? Can you make it again? And that,
Can you redo it?
Nah, dude, you have to iterate. If you do it that way, you have to go through all the mistakes that Claude would make, and then you have to fix them all in the same way. That took the whole like. There's no way that you could just like you recreate the thing. Claude will be just as dumb as it was the first time that we asked him. Like, there's no way. It takes so many iterations, dude.
precisely put.
So many iterations.
Dude, I can't tell you how many times I got into a scenario where it was like, hey, this bug is happening, and it would be like, okay, let me fix it. And then it fixed it, but it created another bug. And I'd be like, oh, you fixed it, but you created a bug here now. And then it'd be like, okay, let me fix that. And then it would the old
Yep.
bug would return and
Yep.
it would just go back and forth. And I'm like, who do I need to yell at? Or you're like, what is happening? How do I anyway?
You got to integrate your Notion.
I was just gonna say you should add a bendy light feature and just put the most arbitrary, random, cartoon bendy lines just to trigger. I mean, just to troll Globers and just leave it there.
Nah, taking them out completely triggers them way more. I found. Like they go to look for the button. They're like, "What? I can't put on." But Ben, there's no button.
Where's the button that
Yeah.
self sabotages it? It's
Leave
like, yeah, we need to
that for
include that
Bislin.
one.
Leave it for Bislin.
Nah, good stuff, fellas. Appreciate the present, man.
Yeah, no worries. And like I said, if you think of any cool stuff to add, let me know and I'll put it on the list. And when I get back to it, I'll knock it out. I just got to get motivated to deal with it again. I spent 2 weeks on it. And I was like, I need a good break from this one.
This is enough, yeah. Because it's gonna be one of those forever projects where unless you just do that, then you'll forever be adding stuff, and people will never be satisfied. Like it'll just be a forever thing. Like Nasty, you gotta beat up because you've been hot mugging the whole time.
Is that the Thug Nasty from Thug Nasty Records Incorporated?
Oh yeah, yeah, you got it.
Yo. All right, well, we're gonna go ahead and wrap up. We'll see you guys around. We'll be back on Sunday for Globebusters. Got a Prezi coming up for that. I think it's gonna be a GPS overview. We're gonna go over some GPS stuff, probably relativity, SAGNAC, ether related type stuff. So we'll be getting into that on Sunday. And then Monday will be the null hypothesis return officially for the we're going to open up with Battle of the Beams. So we'll be covering that on Earth Awakening's Discord and on YouTube on Monday. And then Tuesday will be Ether Cosmology Roundtable 132. So we'll probably be doing some sort of reading night on there as well.